Hi friends, recently I have taken up a new topic in my office. It's called DCDC converter. Yeah, what is DCDC converter? Most of the electric vehicle you can see this kind of batteries inside with multiple connected in series. So this voltage could be in the range of 360 volts. Yeah, but you have a lot of items like this bulb, not exactly this, which is typically working at 12 volts, and you need to convert this 360 volts into 12 volts. Yeah, I would like to do some experiment with items what we have it at home to understand how this DC-DC converter is working. So to do this, I would like to introduce this induction stove. You have a coil inside, and this coil is switching at very high frequency, which produces a magnetic field, and when you put the vessel, this is going to work like a secondary of your transformers. Yes, we are ready. Okay, so you know what is this? This is an LED. It's a normal screw. Put this winding here. Okay, the LED is here. Let me turn it on. It's keep beeping because there is no vessel, but doesn't matter for us. I have some cable, so let us consider this as a secondary. I am going to wind it about this. Okay, so our setup is ready. Basically, we have created a transformer which is open loop now. So you have a primary voltage and you have a secondary voltage you are going to get across this terminal. Okay, so now let's measure what kind of voltage we are getting. Look at the voltage. I'm getting about 3.7 volts. That means per turn is giving close to 1.0 volts. So if I put, for example, another 4 more turns, I can comfortably get 12 volts. I can even blow a lamp, which is equivalent to of a DC-DC converter in a typical vehicle application. Okay, now I'm going to short this and find out how much current it's going to give. Okay, so all we need to do is take out this wire and just create a dead short circuit. You don't need to worry much because your vessel is worse than this. It's a big short circuited vessel. We'll see how much current it's coming. It's about 5 amps. Yeah, it's doing some averaging, but still this cable is giving about 5 amps of current. So the current is typically limited by the thickness of the wire, and probably when I put this vessel it's going to take hundreds and hundreds of amps. Yeah, so it's very difficult to measure this because it's a closed vessel. I think sometimes I'm seeing even 8.2 amps of current. Yeah, so now what happens? Yeah, it's quite warm. Let's do one more experiment. Let me touch again. Gone. Next experiment I want to do is with little bit larger cable and try to generate more voltage and see what happens. So let me pull this out. So in any transformer, the output voltage is basically depending upon number of turns you put it on the secondary. So I don't know how many turns which is inside. I treat it as a primary. So with the secondary, which I can control. So if I want higher voltage as an output, I have to put more number of turns. So what I do is I'm going to wind the secondary pretty easy. So like this, 1, 2, 58, 59, 60. I'm close to 60. Now I need to take out this winding. Yeah, now we got a beautiful winding. 60 turns going to give me close to 75-80 volts. Let me power up. Wow, that's amazing. We'll come back to DCDC topic, that number of turns decides the output voltage. So if I need 12 volts, I can calculate 7, 8 turns. If I want 24 volts, just double it. Now I short this output as I did it earlier with the yellow wire, and I'm going to see how much amount of current is going to flow. We put a lot of turns, right? So do you think that our current is going to be very high? Let's see what happens. Look at that, the current is really low. Last time it took up to 8 amps. Now it doesn't even cross 0.3 amps. Do you know what is the reason? Because this cable, we have put a lot of turns, and increased turns increase the resistance of the wire. So when the wire resistance increases, it's not able to supply a lot of current. So that's the reason we need to have a very thick cable if you want to have very high current. In case we want a high voltage, you need to have more number of turns. I think you can understand the correlation between number of turns and thickness of the cable. The next experiment could be a small DC motor. I want to see what happens. The problem is I cannot directly power up like this, because the voltage what it is getting produced is alternating current. This being a DC motor, it is not going to work. So all what we need is I have to pick my mixed component box. Maybe I have to use something like this called diode, which is going to convert that AC into DC. It's not a perfect DC because I'm going to use only one diode. That's a quick and dirty solution. Let me put this. So what it's going to do is, it's something like a one side valve. So this diode is going to conduct only in one direction of the alternating voltage. So only one side is going to pass, the other side when it is going to get the voltage is going to cut off. So at least the one portion is going to see, and this motor will treat that as a DC voltage. Okay, we are ready. Let's go. Zoom the camera, switch on the stove. Oh my god, that's very shocking. It's a small motor, probably the operating voltage is less. I'm giving very high voltage, probably it's trying to run at very high speed. Let me go back to the old coil and experiment it again. Yeah, how nice it's running, you see. Do you know what is this? Just an iron box filament. Typically you get this inside the iron box. This is made up of nichrome cable, so when you power up, it's going to get damn hot. So it's producing some voltage, close to 1.2 volts. So, but why I did this experiment? Because even though I have more number of turns, but it's producing only 1 volts. If you look at here, there are close to 40 here, 40, 80. It's supposed to generate more than 100 volts, but it's not. You know what's the reason? Because the secondary winding is found over here, and I'm putting this winding somewhere here. So there is no magnetic linkage between primary and secondary. So hence this is not able to produce the voltage. DC-DC converter is everywhere. You talk about any of your mobile charger, laptop adapter, and even inside the induction stove, inside the computer display, any oscilloscope, you will see some kind of DC-DC converter. We call it as SMPS, switch mode power supply, but it's one and the same.